Welcome back, everyone. We're going to be solving LeetCode 107, a binary tree level order traversal 2. So we're given the root of a binary tree. We need to return the bottom up level order traversal of its nodes values. So they give us the tree 3, 9, 20, 15, and 7. We need to return the levels 15 and 7 first, then 9 and 20, and then the root node. So what we can do, this is obviously going to be a breadth first search, but what we'll do is we'll run our initial breadth first search, right? We'll get the output as 3, 9, and 20, and 15, and 7. And then all we have to do is just move these levels, right? We'll move the bottom to the top to the bottom, and the middle will stay the same in example 1's case. So we'll implement our DQ from collections. So from collections, import DQ. We'll set that up to be Q equal to DQ, which will initially contain the root, and we will have a resulting output. We'll have a resulting output, and let's say we'll have output 1 equal to an empty array. So when we run breadth first search the first time, we'll get all of these levels on our array. So let's put these in here so we can see what we're going to do. And 15 and 7. Okay, so this is what our like the original breadth first search will give us, right? It'll give us 3, 9, and 20, and 15, 7. So all we have to do is just run a while loop, and we'll say while this output contains levels, we're just going to pop off the last level, right, which would be 15 and 7, and we can take that off and then just put it onto our resulting output array. And we'll do the same until this output 1 has no more levels in it. And as we can see, it gives us the correct output. So now let's run our breadth first search, which is going to be while the length of our queue is not equal to 0. What are we going to do? We're going to define a level equal to an empty array, and we will say for I in range length of our queue. What do we want to do? We want to grab the node, which is going to be equal to queue.pop left. Now we want to check and make sure we are not at a null node. So we'll say if node is not none. What do we want to do? We want to append the node's value onto the current level. So we'll say level dot append the node dot val. Now we need to check for the left and right children. So we'll say if node dot left is not none. We will append that left child onto our queue, and we will do the same for our right child. So if node dot right is not none, queue dot append node dot right. And then after we exit this for loop here, we are done with the current level, so we can take this level and append it to our output 1. So we'll say if the length of our level is not equal to 0, meaning we have nodes at this level, we will just say out1 dot append the level. Now let's print out our out1 array so we can see what we have now. And we should have the exact same thing as what I showed you earlier. So we do have 3, 9, and 20, and 15 and 7. So now we can just run a while loop. So we'll say while the length of out1 is not equal to 0, we are going to take the very last level, we're going to pop that off and append it to our resulting array. So we will say res.append the out1.pop value. And if you wanted to make this more clear, you could say, what should we call it? We can call it lev, and it will be out1.pop. And then instead of appending the pop value there, we can just say lev. And okay, so let's print out our resulting array after this. Give it some space. And there we have it. We have our, what is this? A level order traversal 2, right? So backwards, essentially. We've got 15 and 7, 9 and 20, and then 3. So all we have to do is just return that output array. And we do pass all 3 test cases, so let's submit. Perfect, it runs. So time and space complexity. Time complexity is going to be O of n, right? We are touching all of our nodes at least once in our tree, but then we are also doing a while loop, right? This is going to be an O of n as well, but O of n plus O of n is going to simplify down to an O of n runtime. And the space complexity is going to be bound to the length of our queue plus the length of our output 1 array plus the length of our resulting array. So we'll say O of queue.length plus out1.length plus our resulting array.length. All right, that'll do it for LeetCode 107.